Assalamualaikum. My name is Tanvir Ahmed Khan. I am a postgraduate student at Assam University of Science and Technology. So this is the part 1 of a two-part presentation on how to start a research project. So the first three topics we're going to cover in this part is problem statement, research gap, and research questions. So doing a research, it's actually a journey. So it begins from asking the right question and it ends by finding the right answer. So every project, every research project begins by identifying three core things. We need to identify a real world problem, a knowledge gap in the existing literature, a clear and measurable research questions. And after identifying these, the next challenges are to determine which research methodology is most appropriate and what evidence is needed, how the data should be collected and analyzed, and finally, how the study can produce valid and reliable findings. So we can set up a research roadmap to begin a research project. So we need to have a research statement. We need to identify research gap, ask the right question. Then we need to identify research methodology, do the literature review, and finally presenting a research proposal, and then summarizing all this in a strong thesis statement. Each of these stages builds the foundation of the next. So we cannot skip one and go to the next. Maybe some skills like literature review and research methodology, they're interconnected and everything. But we cannot skip anyone. So from identifying a problem to defending a specific evidence-backed claim, we need all of this. So in this part, like I said, we're going to cover the first three stages. We have divided the presentation in three modules, module 1, 2, 3, problem statement, research gap, and research questions. The first one, the research statement. Uh, we can also say it's a problem statement. So a problem statement is a formal explanation of the research problem. It must justify why the study is necessary and provide directions for the research objectives and questions. For example, many aging concrete buildings develop cracks earlier than expected. This is very common phenomena. So engineers know that the cracks exist, but they do not fully understand which factors exactly contribute the most under the scenario of local traffic and climate condition. So for the certain factors, how much or how they are going to affect a bridge crack, that is a good problem statement. So there is a good problem here. So to understand a problem statement better, we need to understand what is a problem and what is not a problem. Simply stating, a problem is if the current state is not the desirable state, then it's a problem. And also you can say that problem is what we don't know, but we need to know. A problem must identify an existing deficiency, a knowledge gap, and a need for investigation. So that combination, these three property combination, you can say, is what turns a simple topic, into a research problem. For example, we want bridges to last 100 years, maybe more, but many require major repairs even after 40 or 50 years. So you can see a deficiency. And we have some knowledge. Maybe we don't have the complete understanding. Otherwise, we could build every bridge 100 years lifetime. So understanding why, that's the need for investigation. So understanding why, that is the research problem. So it's important to understand what is a problem and what is not a problem. So what is a problem? It should address adverse reality. So a bad things is happening, like the cracks in the bridges, that's happening, or a good thing is not happening. A breeze is not uh, providing good serviceable lifetime of 100 years. So there should be a adverse reality. There should be some systematic frictions present in there. So difficulties arising from unknown variables or lack of understanding. And finally, there could be some operational deficit, a lack of effective tools to address a known issue. So we know there is the problem, but we don't know how to address it or how to solve it or why it's happening. So these are problems. But what is not a problem? That if there is a mere absence of data, uh, so there could be absence of data in many aspects of our life, but they all are not a problem. And geographic translation. So if we say that this study was done somewhere, but it's not done in our country, like that, the previous example, the cracks are being produced under the subsiding traffic loads in a bridge. So that study has already been done in say USA or somewhere, but that's not done in Bangladesh. But this doesn't mean there is a problem. Maybe that the same solution is universal. We can imply everywhere, so that there is no problem there. It's already solved. Or something arbitrary sample shapes that they studied. Say a research project was done on the adults, so we want to study on the students. So it's not a problem because just only these factors, this could be a part of problem, but these are not necessarily a problem. Uh, for example, a good example should be that existing breeze inspection methods fail to detect early internal damages. But a bad example could be no one has studied breezes in Bangladesh. So this is a statement, more like it. And that alone is not enough unless Bangladesh has a unique conditions. We can say that there are four pillars of problem statement. First one is the context, what we know. So the problem should give some context, like establishing the background. It will provide the current state of knowledge and real world evidence supporting the issue. Then there is the issue, what we don't know. It should be a clear and specific void. Details the exact phenomenon, complication, and conflict that remains unresolved. It should be relevant, why it should matter. So the justification should be there. It will outline the consequences of leaving this problem unsolved and the value of addressing it. And finally, it should also have an objective, how we are going to find it out. The proposed structural approach should be present in there. A brief outline of the methodology, and it will be aimed to uncover a solution. For example, uh, existing bridge performance for a problem statement, this could be a context. And the issue here that for the deterioration, we don't know the cause. It's relevant because safety, maintenance cost, and public impact is there. It can be solved. So the objective is to test and analyze to identify the cause of this deterioration. So module 2 is research gap. So research gaps are basically the opportunity for new knowledges. And there are broadly three types of research gap. First one is insufficient studies, so that a genuine lack of rigorous data targeting specific demographics or specific regions. For example, we may have insufficient studies or very few studies on bamboo reinforced pedestrian bridges. So there is a genuine lack there. Or there could be controversy or conflicting data. So a lack of cohesive understanding is there. So previous studies yielded distinctly different results, creating a competing theories that requires resolution. So one study found one solution and another study found another solution. So that could be a research gap. For example, some studies say that USPC greatly improves durability, and maybe some other studies show a slight improvement. So there is a direct conflict on the results of the previous studies. And finally, there could be limitation present in the past research. So the research was conducted previously, but it had some limitations. For example, for some previous studies, maybe they have considered static loads but ignored earthquakes and fatigue loading on a breeze for some specific factor. So all these could be a good opportunity to gain new knowledge. So if a research gap or void is good, or it's really a good research gap, we can ask a simple question. So what? So if not only the fact that there is a research gap is good enough, it should have some also good characteristics, some specific characteristic to be justified as a research gap. So, for example, if you found a gap in the literature, a gap is without relevance. Is simply, we can call it academic trivia. Trivia. So we need to ask that. So what? There is a gap like this. So what is happening? So there should be some justification. What will happen if this gap is not resolved, or who is directly or indirectly impacted, or what are the future benefits of solving this? For example, if we better say so, if we better predict the breeze deterioration, maybe there is an academic gap there, research gap there. So if we do that, then the government can reduce maintenance cost and prevent failure. So here is the justification for that research gap, for identifying and targeting that research gap. Finally, the third module is the research question, the very important thing for a research, for initiating a research. So there is a dichotomy between research and search. So what is just a search? So it ends in a period and it's Googleable in 3 seconds. You will get the answer, and it yields a single factual answer or simple yes no. So these are just a simple search. For example, what is the design strength of M40 concrete? So it's you'll get 40 MPa. End of that discussion. But what's the research? So research should be multidimensional. So it will branch into a list of avenues to explore, and it will generate factors, variables, dimensions, and it will require systematic methodological approach to answer them. For example, the search question, you can modify it like, how does M40 concrete perform after 20 years under the marine exposure? Now we can see that we're not asking for the strength of only the strength of the concrete, but we are targeting a specific period, like 20 years. How will it perform? So what should be not only the strength, but strength is a part of it, maybe. What will be the strength after 20 years, but also it's exposed in a marine exposure. So there could be many factors like salinity and corrosion, and many things could affect the strain. So each factor has a distinct impact on it. So it's a research question now. Many things can be explored here. Many questions could be answered here. So we can summarize that there could be 7 traits of a good research questions. So first one, it must be relevant. It should be interesting. It should be it should have a balanced scope. So it should neither be too broad or too narrow. And it should be informed. It should be based on previous studies. If the question can be answered in Google, it's not a research. Simply by practical, it probably is not research. And also, it should have clarity, it should be original, and it should be particular. So we can ask ourselves that, can I collect the required data? Can I finish this research within the available time and resource? So these traits are present in a strong research question. And in the research question, we need to also include a methodological pathway. It's not that the exact which method we are not going the broad in this research question portion, but there should be a pathway, a hint of which way the research is going in the research question. It could be either qualitative, it could be quantitative, and or it could be a combination of this system. So qualitative means it should be exploratory, and quantitative means it should be measurable. So the intent is to gain a deep understanding of concepts, meaning, and personal experiences from the exploratory methods. Um, the approach should be fluid, emerging design. Variables are often unknown at the start. And usually the qualitative the pathway is laid by this some trigger words, that how do people perceive something, or why do something happen, what is the role of some specific things. For example, interviewing bridge engineers about inspection challenges, this is purely qualitative approach. Quantitative means it should be more factual, more measurable. The intent should be test theories, calculate relationships, and establish differences. The approach should be rigid, predefined structure, and variables are strictly operationalized. Usually, the quantitative research questions begins with keywords like what is the relationship of some factors or something. Is there a significant difference between something, or to what extent something impacting something? So the quantitative methodology, we're not getting in depth about qualitative methodology, because most cases the methodology is quantitative in the engineering research project. So it can be descriptive. It should measure a subject with precision, um, and also it could have address a correlation, identify association without assigning causes. It could be comparative, establishing difference between different groups. It could be causal, so implicate a direct cause and effect interaction. So here we can dissect a research question. So what should a good research questions have? So we can have an anatomy of an example. So the research questions may be like this: that what effect does the use of ultra high performance concrete have on flexural performance of reinforced concrete bridge girders under static loading? See, there is four component here. There is an independent variable, the use of UHPC. There is a dependent variable, flexural performance under cyclic loading. There is a causal indicator, establishing the structural intent. And finally, it's targeting a specific population. It's targeting the reinforced concrete bridge girders. So if we summarize these three modules, it's like a research funnel. So we are starting in a board with a problem statement, establishing the real world foundation and why. Then we are moving to the research. We're targeting the research gaps, finding the research gaps, and it's narrowing it down. So narrowing the literature to a specific to a specific void in human understanding. And finally, we are asking the research question. So more precisely, we are arriving at a highly actionable and measurable inquiry. Thank you. This is the end of our presentation, the part 1.